We're still in the part work, and I already said something in the video before, which is motive work and resistive work. When we were talking about the work of the weight, and this is what we call the type of work. So, how do we know the type of the work of a certain force? So, if the work of the force that we calculated was positive, then in this case, we'll say that. So, if the work of the force was positive, so in this case, we'll say that the force is helping the motion. It's helping the motion. This means it's this having the same direction as the motion. It's aiding the motion. And in this case, the angle, the cosine of the angle will be positive. Now, if the work of the force, so in this case, we call the work, it's a motive work. If the work of the force, its answer was negative, so in this case, this means that cosine of the angle is negative. So this means F, the force, is resisting the motion. If it was resisting the motion, this means it has to be opposite to the motion. So in this case, we say that the work is a resistive work. And an example of this resistive work of it's the friction, where we know that the friction is always opposite to the motion. Now, in certain cases, the work of the force will be equal to zero, and this is the work of the force is equal to zero, and this is where the cosine of the angle is equal to zero, which means the angle is 90 degrees. This means that the force is perpendicular to the displacement. The case of, for example, the normal reaction. So let's do an example. We have an object that's moving on an inclined plane upward from the point A to the point B. You have the reference down, which is the ground. The angle is 30 degrees and it's moving under the force of value F equal 15 in Newton. We have a friction and the friction is equal to 2 Newton. So the question is calculate the work of each of the forces applied to the object and knowing that AB equal to 2 meters, and we have to indicate the type of this work. So let's do it. We'll start first. So the work of the normal is equal to the normal multiplied by displacement, which is AB, multiplied by the angle between the normal and the displacement. Now the angle between this is the normal and this is the displacement, the angle is 90 degrees. So cosine to 90 is equal to 0, which means work of the normal is 0. Now, work of the force big F, it's equal to the force multiplied by AB, the displacement, multiplied by cosine. Now, we notice here that the force, so this is the motion, and from A to B, and this is the force. So both are parallel and same direction, which means that the angle is equal to 0. So here we'll take cosine as 0, which is equals to 1. So we'll get it's 15 multiplied by AB, which is equals to 2, so equal to 30 joules. Now, let's continue. We have to find the work of the friction, which is the friction multiplied also by AB. But now, if we pay attention, the motion is upward, so it's from A to B, while the friction is always opposite to the motion. So the angle between the two vectors is equal to 180. And cosine of 180 is negative 1, so which means we'll get 2 multiplied by AB, which is 2 also, so equal to negative 4, and we have the negative 1 here, sorry. So we'll get negative 4 joules. We still have to find the work of the weight. So the work of the weight, when it's moving from A to B, is equal to the mass multiplied by G, initial height, which is the height of A, minus final height, which is the height of B. So equal. Now we notice that A is on the reference, which means that the height of A is equal to 0. But B has a height HB. We have to calculate it. It's not given. We notice that HB is opposite to the angle. So in order to find it, we have to use sine. So it's sine alpha multiplied by the hypotenuse, which is AB. And we'll get here, it's 2 sine 30, which is equals to 1 meter. So now we can continue our calculation. So it's the mass multiplied by G, multiplied by HA, it's 0, minus HB, it's 1, So we'll get negative 20 joules. Now, we have to indicate if it's motive or resistive. Here we don't have work. Here, since it's positive, so it's a motive work. Here, since it's negative, so it's a resistive work. It's resisting the motion. And here, since it's negative, so also it's a resistive work.